Okay, so this is 5.2. We're still solving systems of linear equations. Another method or another way to solve systems of linear equations is by what's called substitution. Okay, let's go back to graphing for a minute. That's one way to solve a system of linear equations. Each of the ways or each of the methods are named for a specific reason. If you're solving a system of linear equations by graphing, then you're graphing each of the linear equations. So it might be helpful to get both the equations into slope-intercept form. Okay, another method, like I just said, is what's called substitution. You're substituting the value of the variable in. But let's take a look at each of the steps. And you should also be writing these steps down in your notebook to solve a system of linear equations by substitution. Okay, you want to solve one of the equations for one of the variables. What that means is one of your equations should either be x is equal to or y is equal to. That's a key part of substitution. Then you substitute the expression from step one into the other equation. And I'm going to underline this word other equation. That's important. You never want to substitute back into the same equation and then solve for the other variable. And we'll definitely go over an example of that in a minute here. Maybe pause the video so you can write down each of these steps. Okay, even though it's called substitution, it could be called substitution twice because we need to find the value of each of the variables. After you find the value of one of the variables, you're going to substitute again into one of your equations and solve. Okay, so here's an example. This is my system of linear equations, 2x plus 2y equals 10, and then y equals 5 plus x. Here's what I always say. The first step, solve one of the equations for one of the variables. I always say pick the easiest one. And in this case, the easiest one is this second equation. You should solve it for y because it's already solved for y. Y equals 5 plus x. But here's what y equals, 5 plus x. So in the other equation, since y equals 5 plus x, I'm going to substitute 5 plus x in for y. Then the first equation becomes 2x. That's this first part right here, plus 2 times y. So 2 times the quantity, 5 plus x. Since it's 2 times y, but y equals 5 plus x, that's all equal to 10. Here's what should always happen after you do the substitution part of substitution. You end up with an equation with only one variable. This equation only has x in it, which means we could solve for that variable. So we solve this equation like we did in chapter 1 by first distributing. So it's 2x plus 2 times 5 is 10. 2 times x is 2x is equal to 10. I can combine these like terms. Both of them are on the same side of the equation because now we're solving for this variable x. So 2x plus 2x, that's 4x, plus 10 is equal to 10. Now I could use inverse operations, subtract 10 from each side. 4x is equal to 10 minus 10 is 0. And then divide each side by 4. 0 divided by 4 is 0. X equals 0. Now I want to find the value of y. So I could substitute this into one of my original equations. Doesn't matter which one. I could substitute it in here. This one, in my opinion, should be easier to substitute x into to find y because it's already solved for y. So this is x equals 0. Here you have to be very organized, figure out what you found, figure out what you still need to find. We found the value of x, you still need to find the value of y. Y is equal to 5 plus x, so 5 plus 0 is 5. Y equals 5, and then what we want to do, even though we found the values of x and y, the solution, just like the solution for solving a system by graphing, is an ordered pair or a point. Same thing here. X is 0, y is 5. This is the solution to the system of equations, and we specifically solve the system of equations using what's called substitution.